this is what we refer to as linear interpolation. Let's go ahead and look at what we call linear extrapolation. Ladies and gentlemen, after seeing linear interpolation, we can now move ahead and look at what we call linear extrapolation. Linear extrapolation. Linear extrapolation. Linear extrapolation. Now, linear extrapolation is the opposite of linear interpolation. Now, if it is the opposite, this simply means that whenever we are speaking about linear extrapolation, it deals with computing the values that lies outside the given data. So we can say this deals with the computation of values that lies outside the given data. So when we talk about the value that lies within a given data, ladies and gentlemen, we can easily consider a function y is equal to f of x, and this function y is equal to f of x is given by, you can put them on the table, that if this is our table, ladies and gentlemen, and we have here our x and y. So if we have here our x and y, ladies and gentlemen, then we can have x1, then y1, then we have x2, and then y2, and then we have x0 and y0. So this that lies outside or on the last part of the side, whenever we are dealing with it and we are looking for like x0, which are the last point, then that is what we refer to as linear extrapolation. And remember, whenever we are setting for you numbers, we always combine it, linear extrapolation and linear interpolation, implying that the approach is the same. So whenever we are given this, it is outside our table, then we are going to extrapolate. So this one, if we are to represent it also on our graph, if this is our graph, ladies and gentlemen, are we together? And also brings what we call a straight line. This is our straight line through the origin, and for this case, ladies and gentlemen, we are looking at a point where it is outside, not in the middle like interpolation. So if we are looking at this point, if this is y0 and this is x0 out together, so this is y0 and this is x0. So then this is our, if this is now our, we have that point which is now our y2, then x2. Then we have here y1 and x1. If this is my point A, B, C, as usual, ladies and gentlemen, you realize that also as usual, this will be our x0, y0. Then this will be x2, then this is y2, then this is x1, then this is y1. So at this point, ladies and gentlemen, we can get the gradient A, B. So if we are to get the gradient AB, gradient AB. So the gradient AB, ladies and gentlemen, will be f of x2 minus f of x1. Then over that we are getting here, this, remember that this is f of x. So this is y2 minus y1, the change in that. Then divide by x2 minus x1. then we go ahead and look for the gradient that contains what we are looking for. So we shall also go ahead and look for the gradient BC, and look for gradient BC. So grad BC will be equivalent to fx naught minus this will be f x2 then over x naught minus x2. So if this is the case, ladies and gentlemen, remember that it is a straight line, a linear straight line. So if it is a linear straight line, it implies that these two gradients are the same. So if these two gradients are the same, we shall also go ahead and equate them. So we shall have our fx2 minus fx1 over x2 minus x1 is equivalent to fx0 minus fx2 over x0 minus x2. When we reach at this point, ladies and gentlemen, we shall go ahead x0 the subject of the formula. If we make x0